nicotinamide adenine dinucleotide. It sounds rather complicated, doesn't it? But let's just call it NAD. This remarkable molecule is fundamental to life. It's a coenzyme, a helper molecule for enzymes. Think of it as a tiny, tireless worker. Without NAD, essential reactions wouldn't happen. It's a cornerstone of cellular function. So what exactly does NAD do? Its roles are incredibly diverse and vital. One primary function is converting food to energy. It plays a key part in metabolism. NAD exists in two forms, NAD+ and NADH. These forms are critical for redox reactions. This involves electron transfer, central to energy production. NAD+ accepts electrons, becoming NADH, which donates them. This constant cycling is essential. Discovered over a century ago, NAD is vital for life. First found in yeast fermentation, essential for fermentation. Our understanding has grown immensely. NAD is crucial for all living organisms. Its importance is fundamental. Researchers continue to uncover its influence. NAD is at the heart of cellular operations. It's a central cog in our cells, involved in energy creation and metabolic regulation. Understanding NAD is key to understanding our bodies. Supporting NAD levels could enhance vitality. NAD+, in its oxidized form, is crucial for energy production. Our cells need constant energy for tasks like muscle contraction and nerve signals. This energy comes from adenosine triphosphate, or ATP. Think of ATP as the cell's universal energy currency. ATP is generated in mitochondria, the cell's powerhouses. NAD+ ensures these power plants operate efficiently. NAD+ plays a pivotal role in cellular respiration. Cells extract energy from nutrients like glucose and fatty acids. During glycolysis and the citric acid cycle, NAD+ transforms into NADH. NADH carries electrons to the electron transport chain for ATP production. Without NAD+, the energy pathway halts, limiting ATP production. Healthy mitochondria are vital for overall health and vitality. Optimal mitochondrial function ensures ample energy and performance. Declining mitochondrial function leads to fatigue and reduced cellular function. NAD+ maintains mitochondrial health and supports ATP production. NAD+ dependent enzymes like sirtuins help maintain mitochondria. NAD+ is an active participant in cellular energy production. NAD+ and NADH cycle efficiently to convert food energy. A robust NAD+ supply ensures peak mitochondrial function. NAD+ availability is critical for cellular energy and mitochondrial health. NAD+ is crucial for energy production and DNA repair, maintaining cellular health and longevity. Our DNA faces constant threats from UV radiation, toxins, and internal stress. Damage can lead to mutations and diseases if not repaired. Accumulated errors disrupt cell function and accelerate aging. NAD+ is key to DNA repair, acting as a master regulator. Sirtuins, a family of NAD+ dependent enzymes, play a protective role. They are involved in stress resistance, inflammation control, and DNA repair. Sirtuins consume NAD+ to function. SIRT1 and SIRT6 rush to DNA damage sites using NAD+ for repair. They ensure our genetic blueprint remains intact. This is fundamental for long-term cellular health and longevity. PARPs, another group of NAD+ dependent enzymes, also aid in DNA repair. PARP1 detects DNA damage and signals for repair. It uses NAD+ to create ADP ribose chains, flagging repair proteins. This recruits other proteins to mend the damage. This process consumes significant NAD+. Extensive damage can deplete NAD+ levels. Scientists explore NAD+'s role in aging. Aging cells accumulate more DNA damage and repair efficiency declines. Declining NAD+ levels create a vicious cycle, leading to more damage and accelerated aging. Maintaining NAD+ levels supports cellular resilience and healthy aging. As we age, NAD+ levels decline, affecting energy, DNA repair, and cellular health. Studies show NAD+ levels drop significantly in various tissues, contributing to aging. By middle age, NAD+ levels might be half of what they were in youth. This decline impacts energy, stress resistance, and overall cellular function. Scientists are exploring ways to boost NAD+ for healthier aging. NAD+ declines with age, sparking interest in boosting its levels. Direct supplementation is challenging, so focus shifts to precursors like NR and NMN. NR and NMN are absorbed and converted into NAD+ through natural pathways. NR is a form of vitamin B3 found in foods like milk, but supplementation is often needed. NMN is one step away from becoming NAD+, and is found in foods like broccoli and avocado. Both NR and NMN can raise NAD+ levels, supporting mitochondrial function and DNA repair. Section 6. Direct Approach, the story of NAD+ supplementation. While precursors like NR and NMN are popular, supplementing directly with NAD+ has been explored. It seems logical, doesn't it? If you want more NAD+ in your cells, why not just take NAD+? However, the reality of cellular biology makes this approach complex. The NAD+ molecule is large and charged. These characteristics make it difficult to pass through cell membranes. Cell membranes are selectively permeable, acting as gatekeepers. Oral NAD+ supplementation is less effective than precursors. NAD+ is broken down in the digestive system. The body synthesizes NAD+ from smaller components. Precursors are more readily transported into cells. However, that's not the end of the story for direct NAD+ administration. NAD+ is used in intravenous IV therapy. NAD+ IV drips deliver the coenzyme directly into the bloodstream. Bypassing the digestive system, more NAD+ might become available to cells. IV therapies are marketed for benefits like increased energy and mental clarity. Rigorous scientific evidence for IV NAD+ is limited. Research into how cells take up extracellular NAD+ is ongoing. Some studies suggest cells might utilize NAD+ by breaking it down at the surface. The effectiveness of these pathways is still under investigation. The pursuit of delivering NAD+ to cells continues, with both precursor strategies and alternative methods like IV therapy being explored. Section 7. What the Science Says, Current Research on NAD Boosters. The field of NAD+ research is incredibly active, with scientists around the world trying to understand the full impact of declining NAD+ levels and the potential benefits of boosting them. Much of the initial excitement was generated by studies in animal models, such as mice and worms. In these studies, supplementing with NAD+ precursors like NR or NMN has shown some remarkable results. For instance, researchers have observed improvements in mitochondrial function, increased lifespan in some organisms, enhanced insulin sensitivity, better muscle function, and even neuroprotective effects in models of age-related diseases. These findings have been very promising and have fueled the hope that similar benefits might be achievable in humans. Translating these findings from animal models to humans is always the crucial next step. And this is where research is currently focused. A growing number of human clinical trials have been conducted or are underway to investigate the effects of NR and NMN supplementation. So far, these studies have confirmed that both NR and NMN are effective at increasing NAD+ levels in human blood and tissues, which is a very important first confirmation. Some human trials have also reported encouraging preliminary results, such as improvements in certain markers of cardiovascular health, muscle function, and exercise performance, particularly in older adults. However, the effects are not always as dramatic as those seen in mice. It's important to note what is still under investigation and where the evidence is less clear-cut. While NAD+ boosters show promise for improving metabolic health and physical function in some contexts, their impact on human lifespan or the prevention of major age-related diseases is not yet definitively established. Many of the more profound anti-aging effects observed in animal studies have yet to be robustly replicated in long-term human trials. Factors such as optimal dosage, the duration of supplementation needed to see benefits, and which specific populations are most likely to respond are still active areas of research. The complexity of human biology means that responses can be very individual. Furthermore, science is still unraveling the precise mechanisms by which increased NAD+ levels confer benefits. While we know about its roles in energy metabolism and sirtuin activation, the full spectrum of its effects and how different tissues respond is still being mapped out. Researchers are also exploring whether combining NAD+ precursors with other compounds, like senolytics, which clear out old dysfunctional cells, or antioxidants, might offer synergistic benefits. The scientific journey is one of careful, methodical investigation, and while the initial signs are encouraging, more comprehensive long-term human studies are needed to fully understand the potential and limitations of NAD+ supplementation for health and longevity. Section 7. What the Science Says. Current research on NAD boosters. NAD+ research is active, exploring its impact and benefits. Animal studies show promise with NAD+ precursors like NR and NMN. Human trials confirm increased NAD+ levels, with some health improvements. However, more research is needed to understand long-term effects and optimal usage. Section 8. Safety first. Considering NAD supplements and who might benefit. When considering any supplement, safety is, of course, a paramount concern. For NAD+ precursors like nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, the existing research in both animal models and human clinical trials has generally indicated a good safety profile, especially when taken at commonly recommended dosages. Most human studies have reported few or no significant adverse effects. Some people might experience mild side effects such as nausea, fatigue, headaches, or digestive discomfort, but these are typically not severe and often subside. It's important to remember that these are related to vitamin B3, a nutrient our bodies are familiar with. However, generally safe doesn't mean that everyone should rush out and start taking them without consideration. As with any supplement, it's always wise to consult with a healthcare professional before starting NAD+ precursors, particularly if you have any pre-existing medical conditions or are taking other medications. This is because there could be potential interactions, or the supplement might not be appropriate for your specific health situation. Long-term safety data from very large populations over many years is still being gathered, which is standard for relatively new supplements. Regulatory bodies in different countries also have varying stances on NMN and NR, with ongoing discussions about their classification as food ingredients or novel therapeutic agents. So, who might potentially benefit most from NAD+ supplementation? Given that NAD+ levels naturally decline with age, older adults are often considered a primary target group. The hope is that by restoring NAD+ levels, some of the age-associated declines in energy, muscle function, and metabolic health could be mitigated or improved. Individuals experiencing conditions linked to mitochondrial dysfunction or increased cellular stress might also be potential candidates, although this should always be explored under medical guidance. Athletes looking for an edge in performance and recovery are another group showing interest, though robust evidence for significant ergogenic benefits in highly trained individuals is still emerging. It's also crucial to manage expectations. While the science is exciting, NAD+ boosters are not a magic bullet or a fountain of youth in a pill. They are best viewed as one potential component of a broader healthy lifestyle strategy that includes a balanced diet, regular exercise, adequate sleep, and stress management. For individuals who are young and healthy with already optimal NAD+ levels, the benefits of supplementation might be less noticeable. The research is continuously evolving, and as we learn more, the recommendations for who might benefit most and how will become clearer. The focus remains on supporting cellular health and resilience. Section 9. NAD, a glimpse into the future of cellular health. In summary, nicotinamide adenine dinucleotide, or NAD+, is a truly indispensable molecule, a cornerstone of life that plays critical roles in powering our cells, repairing our DNA, and regulating overall cellular health. Its functions are deeply intertwined with the processes of energy metabolism within our mitochondria and the activity of protective enzymes like sirtuins and PARPs. Understanding its importance provides a fascinating insight into the intricate workings of our bodies at the most fundamental level, revealing how crucial this single coenzyme is for maintaining vitality and resilience throughout our lives, from our very first breath. We've seen that a key challenge is the natural decline of NAD+ levels as we age. This reduction is linked to increased consumption by enzymes like CD38 and PARPs, which are often more active due to accumulated cellular stress and DNA damage, as well as potentially less efficient NAD+ production pathways. This age-related depletion is thought to contribute to many hallmarks of aging, including reduced mitochondrial efficiency, impaired DNA repair capacity, and diminished cellular stress responses. This understanding has, quite naturally, spurred considerable scientific and public interest in strategies to counteract this decline and support NAD+ levels. The development of NAD+ precursors, such as nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, offers a promising avenue for boosting cellular NAD+ levels. Current research, particularly from animal studies, has shown encouraging potential for these compounds to improve various aspects of health and even extend health span. Human clinical trials are actively underway, confirming their ability to raise NAD+ levels and beginning to explore their impact on metabolic health, physical function, and other age-related parameters. While much has been learned, there is still a great deal to uncover regarding optimal dosages, long-term effects, and specific benefits in diverse human populations, ensuring researchers remain busy. Looking ahead, the future of NAD+ research is incredibly bright. Scientists are not only investigating the benefits of existing precursors, but also exploring new ways to enhance NAD+ metabolism, perhaps through novel compounds or combination therapies. The goal is to move beyond simply slowing decline and towards actively promoting cellular rejuvenation and resilience. As our understanding deepens, NAD+ biology may well become a central pillar in strategies aimed at extending human health span, not just living longer but living healthier for longer. The journey to fully unlock the potential of this vital molecule is ongoing, offering exciting prospects for the future of preventative health and healthy aging.